Good morning. Good morning. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, July 26, 2021, Monday, and talk of quality safety in general life, in professional life, and others. Title being Civil Field Engineering Quality AnnexSL COVID-19 SHE Engineer's Role in Safety and COVID Designs, Construction Methods, Contracts, Organizations, Communications, Coordination and Quality Reasons and all. Different talks, certifications. And the respect comes only in your work, your work. If work done by you guys doesn't meet quality requirement, your certificates do not support your personality. This supports that you are careless, you are not professional, or you are professional only for selfish nature. Don't mind it, please. It's a fact. What we expect is quality, safety, health, and environment in every sector of life, including engineering. But that expectation is not fulfilled. That is very bad, you can say, bad work, bad personality, and which requires cutting and welding. In fact, every engineer, every professional requires these certificates cannot answer everything. Only work can answer, quality can answer, nothing else. Quality is part of life, but in fact, it's not part of life. That's problem here. We always talk of quality and we respect quality. Quality every day I cannot explain this way or that way. I think if you are interested, you have to learn. You have to use your values, your knowledge, and learn it. That's an only way we can get quality improvement. Yesterday I was talking about welding and also quality as usual. Quality should be a part of life. It must be a part of life. But unfortunately, it's not a part of our life, as I explain all time. For many years I have been experiencing, not only in this country but also in other countries, but now I'm talking about this country, Bharat, India, where quality actually is in minus rather than being at even zero. I can say quality does not exist anywhere in any branch of engineering or in other non-engineering sectors. Quality is not meant what it should be. It has been used as a reference only. Every organization, every establishment thinks that having certifications of third party quality certification agencies, we can achieve whatever we want. Certification, I think, of quality also have downgraded nowadays. Everybody claims that it is certified, but when you compare it to, when you evaluate that one to product, when you evaluate it to product, standards of product, well, I don't find any quality, and that's where I'm serious about. Quality requires input. Quality requires determination. Quality requires a system. Quality requires implementation of that, and genuine system, not copied system or system just to show but not to do. That system is useless because to whom you want to show. We know manufacturer or factory owners or others who deliver some product or some service. They expect that customer should be happy. Customer should get back what for customer pays, and even more than that, because more than that what is expected is defined as value of product, value engineering. In our engineering technology, in our engineering terminology, we call as added value or value addition. I cannot demand value addition when value is not available. Products are not quality oriented. In general, it is seen. You go and visit any work. You go and visit whatsoever work. I'm not specifically telling go there and there. Go and visit yourself if you are a professional. Even if you are not a professional, you go in either sector, in government sector, in private sector, you shall not find standard of quality. Even if you are not aware of what standard should be, your eyes will tell you, your mind will tell you there is something wrong somewhere, it's not quality product. You buy whatever product, consumable or non-consumable, what you expect you shall not find that. What you pay for you shall not find for that. And this is very much general. I don't have one example, I have many examples, and I don't want to reiterate all examples. It may be construction site, it may be design work, it may be factory work, it may be whatever services you get. Quality now has become a question by everybody, though people don't raise voice. I am raising voice on behalf of everybody that quality is my part, it is my right, because I pay for that. You tell clearly, if this is price, there is quality, and if this much is price, this is quality, and if this much is price, this is quality. Or you don't get quality if you pay below that price. But when you write MRP on product, there is no question of classification of quality and classification of price, because your MRP tells whatever is given to you is according to this description or according to standards one. Then there is question of nullifying that. You declare something, you have to give. When I say you, it means manufacturer, it means industrialist, or it means professional service provider or other service providers. Because you are paid, you have to deliver it, and if you don't deliver it, you do a kind of bad service. You are not a service provider and you are not a good manufacturer. Sometimes you reduce quantity as well, standard quantity of your unit, and quality is never nowadays is given input into that product. My question is about quality, and of course safety is along with quality, because without safety work can't be done. Factories cannot work without safety arrangements, safety requirements fulfilled. If not fulfilled, they won't work. Workers won't work. But are they aware of that? That is a question mark. Maybe they have standard works in factories. Safety is a big question mark because they must be availing safety, or else it's a question of life and death. Mechanical people might be, they are working under safety, I cannot say. I have not very good experience here. Same way electrical people, because they get shocked, so they work with safety. But generally, Generally, there was a time when driving a car or using a car, using other seat of non-driver, people did not like to use seat belt. I don't know reason behind that. Still, they use seat belts because of challan or because of some other reason. Means you want to even drive free of seat belts. Now you are bound not to do that. Same way, quality is just for name's sake. Quality is just for name's sake. It has nothing to do in real life. If you get very good product according to requirement, you are lucky or fortunate. You are fortunate that you get back price of your money. But in 99% cases, I am sure you shall not find quality. You buy a car, you buy a computer, you buy a house, you buy whatsoever you can. You spend money. Decoration you will find, finishing touch you will find, color you will find, everything you will find. Good cover seats, cover on seats you will find. And the seller would claim, manufacturer would claim, this is best in service. This is the best car. This is the best product. Everything is best from every manufacturer. Everything is claimed best. If everything is best, they would say you compare with other products, and they will give comparative list which you can never understand. Yes, they will give 3 or 4 or 5 points where you can understand, but other points which are really comparable they won't give. And even if they give, you may not understand them technically. So they know where customer can be convinced. Every manufacturer, every industrialist knows very well how consumer or customer can be contained in, I should say, means can be made, can be forced indirectly, can be forced to accept what you say, or there is no alternative under budget. You can say you have certain budget, and in that budget you cannot buy something else more than this. But you are a customer, they will treat you like a customer, but material shall be under quality or substandard, which you will not know at that time, because that time you will be respected because you are paying money. And once you come into trap of that sales, you own that material or product. After that, there is a warranty for 1 year or 2 year on every product. But I don't call that material warranty. That is warranty against failure warranty. I have now different understanding of warranty or guarantee. These are all fake warranties. In fact, 1 year warranty, 2 year warranty, these are fake warranties. They just try to give you a warranty so that you don't ask anything. You don't raise question. That is meaning of warranty, nothing else. Yes, they know that within this period, this material shall not suffer, this product shall work fine. They trust, that trust they have. That trust they have, and that trust is their convincing power. This trust gives a convincing power to them that they can convince customer and consumer. My question is, general question is, why should I care about warranty? When I pay money, I pay for good product, for quality product, and I expect that whole life that product should work successfully. That's my understanding. And even then, after that, I am trapped by quality, warranted quality it has. When warranty means product shall perform, and that performance means product is made according to your requirement or according to specification. That's what warranty means. But a product, if you buy, say, you expect that that product should work for 10 years or for 8 years or whatever number of years life may be of that product. Do you expect that in 1 year or in 6 months or in 1 week time we have to call that service, that manufacturer for service? You think that? Nobody thinks that. Nobody thinks that. It's a product. It's a lifetime. And they warranty that you have an surety. You have surety that this product shall be set right. But why you think that 1 year warranty is enough for 10 years product? Why? Why should I think that? Means there is something wrong somewhere, that's why you are giving only 1 year warranty. Why do you want to give 1 year warranty and why should I accept that? Because this is game plan. Just to keep customer shut up, calm. Customer has no alternative. Okay, I pay product for product purchase, and within that warranty cost, warranty expenses are also included. Means even in that case, manufacturer is not doing any special favor to you. It's costly, expensive. Price is included in production. What is the price is there, and maintenance during warranty, repairs during warranty. This means there is no uniformity in manufactured products and spare parts contained within product. There is variation of life. That's why this is a 1 year warranty. When 10 years product I buy, why should I worry about warranty? It should work for 10 years or at least half life if not full life. It should be durable warranty, it should not be temporary warranty. And if it's 1 year warranty or 2 years warranty, after that, after warranty is over or post warranty, what should be done? Then there's another expenses you have to make, that you have to take AMC, annual maintenance contract. Means they get money in that also. So this warranty is a line, silver line, after which your price is over. Means whatever price you paid during at time of purchase, that price covers cost of material, cost of its warranted maintenance and service, and profit. That price contains this. And after that warranted period of 1 year or 2 years, you have to buy AMC from that manufacturer or its agent. And that AMC shall continue every year forever. This means within 5 or 6 or 10 years, if you take AMC, price will be at least twice or thrice the original price. And we all accept warranties, and without warranties are also, AMC's warranties are also not very much clear. But I will not go into that. My submission is that, is it right to be cheated by these non-professional manufacturers? I am calling non-professionals because they claim they are experts, but they are not experts. They are only commercial people. Of course, technical support they have. With that technical support is abused for commercial interests only, not for consumers' performance interest. Consumer accepts service for performance, accepts product for performance, but that doesn't result in positivity. We have to concentrate on this. Quality, though it's considered secondary, but I stress that it is top priority. If no quality means product should not be accepted. Should not be accepted. It should be thrown back on heads of the manufacturer with bombarding statement. That's only an answer. All have become master-minded. All have become rubbish. All are only interested to sell product. Whatever one be, however big one be, at international level also it happens. My statement may be harsh, but it's full of facts. And I understand facts work in engineering and nothing else. Facts work in engineering. That is my first understanding. Without facts, engineering does not work. And facts that product should be quality and should be safe for everybody, though safety is involved during production. It's not involved during performance, but its performance should not be down to that level where safety is also compromised. We'll talk of this little later, but now my focus is on standards. I know maybe you say every day he talks this without any target. You can say that. How can you fix target on such manufactured units or quality required services where everybody is on same track of no quality? There could be exceptions. I'm not saying that there could be some exceptions. Everywhere there is 1%, 2%, say 5% maximum, where people are serious. But otherwise, seriousness does not exist in anyone. It may be manufacturer, it may be industrialist, it may be other professionals like engineers, like others who are responsible to build society. Build means originally build. Engineers are called agents of society, agents of change, because whatever exists today in form of physical development, material development, that is due to all engineers and engineering world. Engineering world doesn't mean civil engineering here. This means all branches of engineering which are real engineering. I'm not including in this IT service, though even IT service is also that level. But IT is different. You can't understand IT directly. You can't analyze it directly because it's based on something else. But where you pay money for everything and want to use that for years, even though computers are used for many years, softwares are used and amended and modified, yet you can say quality in IT also absent. Is also absent because IT is not yet perfect one. There is so much required on it still now, and IT also has been made a profession or a business. Every day while updating something here and there, download this and download that, or automatically update it. This means quality question also arises. Today there is some updated software. This means my 5 years old software may not be fitted in that. So that's also indirectly you can say a commercial establishment. When commerce come to picture, I mean to say irreasonable commerce. There's acceptance up to some level because of requirements of their profit. But when it goes beyond that, that is, you can say, indirect polite loot of its customers. I can say polite loot because these people are more interested in polite language. These people who are involved in manufacture or who are involved in sales or dealing with customer, you can call customer support. They are more interested in polite attitude, polite expectation of everything, despite the product is politely rubbish. You have to be polite. You have to request them as if they are your owners. You are not owner. Customer is owner, but they think customer is nothing. They are owner. This is, foolish learning, foolish understanding by them. They know customer satisfaction is required. They know only, and that's all. Knowing is not application. It's enough. They don't care for customers. I have experienced this not once, not twice, many times. I don't want to repeat whatever I repeated before, and I can say that it is only it's only one community in this world, in our country, that's known as engineering world, engineering community, because engineers are responsible in every branch for production, for manufacturing, and for doing whatever is done, even in sales. It is engineering world, it's engineering community that can change society, and engineers are called change agents. Still they are change agents, and they have to keep update information with them and act on that. If they only know and are unable to act, I can't say that they are professional one. A professional one means whatever advancement has been made in that field, it must be understood, it must be known, however small or whatever size big it is, it's to be known. That where quality lies in, and that's where interest lies in. Speaking is very easy, and we know doing is very difficult. Claim is very easy, but responsibility on claims is very difficult. In name of warranty, you can befool people, and people have no other option other than accepting what you say. But remember, even if people don't speak, they burn, self-burn. They are self-critical, because who has time to go back to shopkeeper or to industrialist or to manufacturer to complain about? Everybody has not that skill. Everybody doesn't have that skill. Everybody cannot be so serious to fight for products, bad service, products, bad performance. It's not one product. Whatever you buy, which is not natural, which is man-made or man-produced product, has certain deficiencies all time. It should not be there. Facts state that should not be any deficiency, so that bad performance is avoided. But that, you can say, a disclaimer is very good term. It's very easy term and comfortable protective measure. Just put a disclaimer on something, or even on some document, that since everything is beyond our control, and if you violate these conditions, even this warranty is void. It's very easy. Put any disclaimer and enjoy. So there's no claim on that. There's no claim. And moreover, when you buy something, it's clearly written in general cases that once a material is sold, it shall not be returned. Means you are made slave of those manufacturing people who say that this material shall not be taken back, even if it's not quality product. They know that consumer does not understand quality criteria. That's why they abuse all this. There is only simple question without using mind. Give me what I pay for, and that's it. Nothing else. I am simple being. I have very little knowledge. I just say, give me back what I pay you. Is it wrong? Tell me. I don't need any discount. I don't need any specific favor from you. I don't even need free home delivery. Forget it. Charge for delivery. But give me good product, reliable product. When I say reliable, which means this product should perform, this product should be active, this product should be safe, during performance, during its production, during its delivery, and during its performance. That factor, a combination of such factors and many more in that, can be called reliability. So I am interested in reliability because I should not feel money that I paid has gone to no warranty. People say we have this certificate, ISO 9000 or Sigma related certificate. They claim on papers, they claim on documents, but they do not know what happens on ground, in floor or on site. Our workers are great. Our professional workers are great. In every branch of engineering, they are not highly qualified, but they are committed to work. They know how to work. But working is one part. What is to work and how it is to work, that's another part. Work can be done according to instructions are given or according to system is adopted. But work is right or it's wrong, it's per requirement of quality or not per requirement of quality. It depends upon certain other requirements, certain other facts. If I don't get what I expected, certainly my mercury would go up. After all, I pay and I expect that service. And if I don't get that service, it's really unacceptable. Because quality is very bad everywhere. I cannot use specific names, but many top companies, national level companies or international level companies, who always are interested in publicity stunt, they never tell about products. They just tell our product is best. You can compare with other services or products and you can know difference. Just to keep themselves covered, they use so many documents that first of all you cannot read those documents. They use their own format for that, and they only can understand, and they always have a right to change procedure or document or machinery because they spend money and they want good service. But that should be charged back to a person who was responsible for quality of that system. I will not go further more in this. Quality is very important, I can only say, and I can only say that it should be complied with. It should be complied with demanded or defined requirement. When I say defined, this means demanded as well, because I demand that quality. I expect that quality. I am not demanding any favor, no favor, because I am paying for your business. I pay for that product, and when I pay, I must be given back value of that money I paid through performance of this product. That is basic. And if you can give me more, it's fine. Then I'll think to buy more and more. Simple. Because you have started trust with me. You have established trust for that. So we can say, yes, quality is complying. Means they are good people, they are professional, we may say, and we will not like to appreciate, rather say, this is professional work and they are professionals, they are doing. What's specific in that? So it depends on compliance of quality, if we can do, and absence of quality means no future. Engineers must realize quality facts, because facts are part of engineering world. It may not be prescribed in writing, but facts still remain that You can't go free if you don't do quality work. God also tried to give quality work, but God was God and people are people. That's the difference. Our quality system is questioned by me and like by many others, because these vendors, whoever they are, shopkeepers, whoever they are very smart. They are very smart in managing quality and safety. They don't care. They expect only something. That expectation is that product should be built and sold. Your product is going to be used for many years. For sure, it should work. It should work. But when you experience, you will find a difference that this product cannot work for so many years. Engineers must realize facts. Quality is a fact, just like material or good is a fact. Quality is a fact and cannot be abundant, but practically it is abundant. It has been abundant. Society can be built only when everything is fine. Otherwise, society is also, you can say, fragile. With one attempt, it can be destroyed, or it can be, you can say, ill-cultured. Ill-culture. Construction based on reasonable, coordinated, constructible quality. Construction applies everywhere. In fact, construction is real word. When we say manufacturing, what does it mean? Manufacture. What does it mean? You can say manpower, human power. We can say that's manu, M-A-N-U, and facture. Facture. What does it mean? It says fact. It doesn't say what fiction. It says manufacturing and not manufacturing. Manufacturing or fictionary. It's called manufacture in industries or factories, and this manufacture is dependent on how human thinks and what should be service given through this manufacturer to human or to consumer. So manufacturer terms is defined there. It's not a joke. Quality is never a joke. Quality is a requirement. We can't say no. All activities must be taken care of, but it doesn't happen. Reasons being lethargy in attitude. That is number one. Lethargy in attitude of every individual. Because lethargy, you understand what is lethargy? And undue strains in mind. Undue strains in mind. Undue strains means anything you can say in your life. What is undue? What should be done? What should not be done? Yes. Hello. I can't view. Show me what you want to show. Hello. You are not clearly seen. I am not able to see clearly. Hello? Come on, tell me what you want to say. I'm not, I'm not, I'm not able to see. You see, quality now I'm talking. It is very serious matter. It's very much important matter. And it's not important for one person. It's very much important for everybody. It may be this country or it may be some other country. Quality is expected everywhere. I don't want mobile answers. I'm not interested in your SMSs. I'm not interested in your talks. I don't pay for that. I pay for product. I'm not interested in your questions. I'm not interested in a help guide. I am interested only in product because I pay for product. I don't pay for talks. If you want to talk, talk to yourself. Don't talk to me. I want product quality. That is only one objective I have when I buy something. That is only an objective I have when I buy something, and if I don't get anything. That's point here. If I don't get anything, I don't value it. If I don't get that, there is no meaning. Nothing is useful if I don't do it. Well, what can I say? I don't know. What can I say? As undo, not clear anything. Nothing is clear. Waste of time. Nothing is clear. It's complete waste of time. No clear picture. Nothing. Darkness only. Only darkness. I don't know. Some people call and they don't speak. This is also, I can say, bad quality. Well, I think everybody may be feeling, bored by my talks. I'm not making you entertain something. I no interest in your happiness or to entertain. You spend your money, I'm talking about that. You buy something, I'm talking about that. I am interested because people do not understand. I know quality has gone out of our society, of our country. When a society or economy, I say, this is questionable. It applies to country. Nation, it applies to nation, and even our definitions of qualities are absent. I have an understanding, even engineers who are high profile, they too take it on low profiles these days. Low profiles. A kind of understanding has been developed practically. Let it go as it is. Let it go as it is doing. Because there's no meaning in applying force on that. Because it's not going to change. That type of attitude has been developed. You may write, it's like I'm speaking now, you may make videos, you publish. People are not interested. You may write anything, whatever you may write. They're not interested, particularly youth. Youth, always in every age, youth is at stake. Youth is at stake of everything, but I don't consider it as right. Youth means youth means one has to learn. Youth doesn't mean only responsible. Youth has to learn. Youth has to mold to culture. Youth has to do a lot. Youth is energetic. Youth has energy quality. Youth has anxiety quality. Youth has hunger quality. Youth has to turn to mature. Transformation of youth stage to mature stage is required, and that's where quality input is given. Because youth was student one time and had to learn. Then youth converted to adolescent, and that was also learning time. And now youth is fully qualified but not experienced. It's very big challenge, because if experience is based on bad quality, youth shall learn only bad quality. If experience is based on good quality, youth shall learn good quality. So you can say this period of youth, a couple of years, belonging to youth in field, in work, shall cast or mold that youth's character about quality requirement. If quality seriousness is not injected, if quality seriousness is not injected or inculcated into this youth shall turn to be different type of person, least bothering about seriousness of quality, but only thinking of, just like many professionals think, savings and profit only. It's a very serious issue. There is so much discussion that can be held on this. We can deliberate for hours and days on this issue, because it applies to whole nation, particularly when we talk of ours. Facts cannot be denied. This is also factual. You cannot deny facts. If facts are denied, everything is denied. We have to learn facts. We have to believe facts. Facts only can be believed, not imagination, not speculation. Facts always tell you something. Weaknesses are known through facts. Weakness is known through facts. This point we should know. Nowadays, and for last more than 18 months, 19 months, God has been busy in teaching us. God tries to teach us, still trying to set ourselves right to requirement. We have to serve ourselves. We have to serve our clients. We have to serve everybody who is in that loop. Loop means loop where quality moves place to place, from place to place. Safety moves from place to place, and system is established. I'm talking about that. It's not futile talk. This talk is very important, because we have to open our eyes. We have to open our minds. Engineers must open their minds and eyes, because engineer is that only professional that can be hit by quality and that can hit others by quality. Hit means impact. If engineers don't care for this, I think it's horrible. Horrible. It's like ghost work. If engineers can't care for quality, I can say then we are destroying ourselves. We destroy ourselves. We disintegrate ourselves. Engineer's fundamental duty is quality creation, quality doing. It may be on papers or it may be in factory. It's a part of spare parts or product manufacturing. It may be production industry. It may be whatever else. Engineers are responsible for everything. For design, for manufacturing, for construction, and then teaching all others. In sales, engineer cannot be used only for production or for production efficiency. Engineers are responsible for everything because field working is in hands of engineers. If they cannot work in field, coded way or agreed way, where quality can be defined to be achieved, and examples may be there, history may be there, but now where is that history? Where is that history? You should understand, is to explain to their family what is quality, what is required. Well, very boring talk. I move to something else now. I think I'll continue this. Let's go to something else also now. I was talking of welding and cutting, which is very important one, and I downloaded some Wikipedia page about welding, and we talked about welding, what is welding, how it works, what is the little history of welding. We talked of what is this term, how it worked, we talked of history, we talked of, and then I can say we talked a lot on that. Then we will talk on processes, what is arc, what is power supplies in that processes. Then we talked of sheet metal arc welding, other arc welding, all that we talked of. What is field, heat field, and we can say all these definitions I am trying to show you what discussed. And we were at somewhere, I think we were at heat affected zone. That's very much of interest. Heat affected zone. I leave it to you for a couple of minutes so that I can go to terrace and do what is required to be done for a little while. You can rest assured by that time I'll be back and continue this technical discussion, which is about 8 pages. Then I will come back to statement, and this is very important page for general knowledge as well, others. So meanwhile, have rest, keep on this visual, read it, understand it, and I'll come back that time. We are finding here something now which is different, one more than this, and that's you. No, I mean to say, it's time for a retrospection of what we did. Of course, I can say that we can say now I'm talking about welding, and it was heat affected zone we talked of yesterday. How to find heat input, how to find heat input, that's very important one. How to find heat input, heat affected zone which we call HAZ, heat affected zone which we call HAZ is a ring that surrounds weld in which it's a ring surrounding weld in which temperature of welding process combined with stresses of uneven heating is a definition of heat affected zone. It says it's a ring surrounding weld in which temperature of welding process combined with stresses of uneven heating and cooling alters heat treatment properties of alloy. Means by welding heat treatment properties of alloy can be altered. Effects of welding on material surrounding of weld can be detrimental. Effects of welding on material surrounding weld can be detrimental depending on materials used and heat input of welding process used. Heat affected zone can be of varying size and strength. Thermal diffusivity of base material plays a large role. Thermal diffusivity of base material plays a large role. If diffusivity is high, material cooling rate is high. If diffusivity is high, material cooling rate is high, and heat affected zone is relatively small. Conversely, a low diffusivity leads to slower cooling and a large heat affected zone. So there are two, one is large heat affected zone and other is small heat affected zone. Can say 2A means small area affected zone area or large affected area. High diffusivity means cooling rate is high and relatively small zone or large zone. Amount of heat injected by welding process. Amount of heat injected by welding process plays an important role as well. As processes like oxyacetylene, welding have an unconcentrated heat input and increase size of heat affected zone. Processes like laser beam welding gives a highly concentrated, limited amount of heat, resulting in a small HAZ. Process like laser beam welding gives a highly concentrated heat input and increased size of heat affected zone. Process like laser beam welding gives a highly concentrated, limited amount of heat, resulting in a small heat affected zone. Arc welding falls between these two extremes, that is oxyacetylene and laser, with individual process varying somewhat in heat input. And to calculate heat input for arc welding procedures, formula can be, that's for arc welding I say, Q is equal to heat input, that's kilojoules per mm, which is equal to voltage into current VI, and then 60 multiplication over S, which is welding speed in millimeter per minute, multiplied by 1000, and this bracket multiplied by efficiency. Efficiency depends on welding process used. With shielding metal arc welding, having a value of 0.75 in efficiency, gas metal arc welding and submerged arc welding 0.9 higher than that, and gas tungsten arc welding 0.8. Method of alleviating stresses and brittleness created in HAZ include stress relieving and tampering. Now, lifetime extension with after treat methods. Lifetime extension with after treatment methods. Durability in life, can say durability and life of dynamically loaded welded steel structures. Durability and life of dynamically loaded welded steel structures is determined in many cases by welds, in particular weld transitions, through a selective treatment of transition by grinding, abrasive cutting, short peening, high frequency impact treatment, etc. Durability of many designs increases significantly. So what do we say? Durability and life of dynamically loaded welded steel structures is determined in many cases by welds, in particular weld transitions, through selective treatment of transitions by grinding, abrasive cutting, short peening, high frequency impact treatment, etc. Durability of many designs increases significantly. Is a photograph of example, high frequency impact treatment of lifetime extension. Now metallurgy. Most solids used are engineering materials. It's not giving that correctly, so I take it 140 better. So it's okay. Most solids used are engineering materials consisting of crystalline solids in which atoms or ions are arranged in a repetitive geometric pattern, which is known as lattice structure. Again I say, most solids used are engineering materials consisting of crystalline solids in which atoms or ions are arranged in a repetitive geometric pattern, which is known as a lattice structure. Only exception is material that is made from glass, which is a combination of supercooled liquid and polymers, which are aggregates of large organic molecule. This is very important statement here. Definition of this material says only exception is material, means lattice structure is there in everyone. It says most solids used are engineering material consisting of crystalline structure, crystalline solid, in which atoms or ions are arranged in a repetitive geometric pattern, which is known as lattice structure. And only exception is glass, which is combination of supercooled liquid, glasses, supercooled liquid, and polymers, which are aggregates of large organic molecules. Crystalline solids cohesion is obtained crystalline solids, cohesion is obtained by a metallic or chemical bond that is formed between constituent atoms. Chemical bond that is formed between constituent atoms. Chemical bonds can be grouped into two types consisting of ionic and covalent. What are chemical bonds? It's ionic and covalent. Chemical bonds can be grouped into two types consisting of ionic and covalent. To form an ionic bond, either a valence or bonding electron separates from one atom and becomes attached to another atom to form oppositely charged ions. Bonding in static position is when ions occupy an equilibrium position where resulting force between them is zero. When ions are exerted in tension force, inter-ionic spacing increases, creating an electrostatic attractive force, while a repulsive force under compression between atom nuclei is dominant. Says when ions are exerted in tension force, inter-ionic spacing increases, creating an electrostatic attractive force, while a repulsive force under compressive force between atomic nuclei is dominant. Covalent bonding happens when one of constituent atoms. Covalent bonding happens when one of constituent atoms loses one or more electrons. This is covalent bonding, means if some atom loses one or more electrons, with other atoms gaining electrons, resulting in an electron cloud that is shared by molecule as a whole. In both ionic and covalent bonding, locations of ions and electrons are constrained relative to each other, thereby resulting in bond being characteristically brittle. So, a covalent bond and bond that is ionic. See, ions are exerted in tension force, inter-ionic spacing increases, creating an electrostatic attractive force, while repulsing force under compressive between atomic nuclei is dominant. So, bond in static position is when ions occupy an equilibrium position where the resulting force between them is zero. Covalent bonding takes effect when one of constituent atoms loses one or more electrons, with other atom gaining same, resulting in electron cloud that is shared by molecule as a whole. In both ionic and covalent bonding, location of ions and electrons are constrained relative to each other, thereby resulting in bond being characteristically brittle. Metallic bonding can be classified as a type of covalent bonding for which constituent atoms are of same type. Covalent bonding in which constituent atoms are of same type and do not combine with one another to form a chemical bond. Atoms will lose an electron, forming an array of positive ions. These electrons are shared by lattice, which makes electron cluster mobile. As electrons are free to move as well as ions, for this it gives metal their relative high thermal and electrical conductivity as well as being characteristically ductile. Metallic bonding can be classified as a type of covalent bonding for which constituent atoms are of same type and do not combine with one another to form a chemical bond. Atoms will lose an electron, forming an array of positive ions. These electrons are shared by lattice, which makes electron cluster mobile, as electrons are free to move as well as ions. For this, it gives metals their relatively high thermal and electrical conductivity, as well as being characteristically ductile. Three of most commonly used crystal lattice structures in metals are body-centered cubic. Which are lattice structures in metals? These are commonly used: body-centered cubic, then face-centered cubic, and close-packed hexagonal. Body-centered cubic, face-centered cubic, and close-packed hexagonal. Ferritic steel has a body-centered cubic structure. Ferritic steel has a body-centered cubic structure, and austenitic steel, non-ferrous metal like aluminum, copper, and nickel. Ferritic steel has a body-centered cubic structure, that is body-centered, that is cubic structure is ferritic, and austenitic steel, non-ferrous metals like aluminum, copper, nickel have face-centered cubic. So we can say ferritic steel has a body-centered cubic structure, and austenitic steel, non-ferrous metals like aluminum, copper, and nickel have face-centered cubic structures. Ductility. Nickel have face-centered cubic structure. Nickel. Ductility is an important factor in ensuring integrity of structures by enabling them to sustain local stress concentrations. Ductility is an important factor in ensuring integrity of structures, by enabling them to sustain local stress concentrations without fracture. In addition, structures are required to be of an acceptable strength. In addition, in general, you can say, in addition, structures are required to be of an acceptable strength, which is related to material's yield strength. In general, as yield strength of a material increases, there is a corresponding reduction in fracture toughness. A reduction in fracture toughness may also be attributed to embrittlement effect of impurities. Impurities are for body-centered cubic metals. From a reduction in temperature, metals and particular steels have a transitional temperature range. Metals and in particular steels have a transitional temperature range where above this range metal has acceptable notch. Ductility, notch ductility. So I can say a reduction in fracture toughness may also be attributed to embrittlement effect of impurities or for body-centered cubic metals. From a reduction in temperature, a reduction in fracture toughness may also be attributed to embrittlement effect of impurities or for body-centered cubic metals. From a reduction in temperature, metals and particular steels have a transitional temperature. We can say now it's gone through reduction. A reduction in fracture toughness may also be attributed to embrittlement effect of impurities or for body-centered cubic metals. From a reduction in temperature, metals and particular steels have a transitional temperature range where above this range metal has acceptable notch ductility, while below this range metal becomes brittle. Within range, material behavior is unpredictable. Material's behavior is unpredictable. Reduction in fracture toughness is accompanied by a change in fracture appearance. When above transition, fracture is primarily due to micro-wide coalescence, which results in fracture appearing fibrous. When temperature falls, fracture will show signs of cleavage facets. Fracture appearing fibrous when temperature falls below, fracture will show signs of cleavage facets. These two appearances are visible by naked eyes. So we can say here these two appearances when temperature falls, fractures will show sign of cleavage facets. These two appearances are visible by naked eye. Brittle fracture in steel plates may appear as chevron markings under microscope. These arrow-like ridges on cracked surface point towards origin of fracture. So we have here definition of ductility and also fracture. You can say it says reduction in fracture toughness. That was the point in ductility. I repeat, ductility. It's important one to understand clearly because there are ferritic steel with there are three of most commonly used crystal structures, lead structures, metals bound in body-centered cubic, face-centered cubic, and close-packed hexagonal. Ferritic steel has a body-centered cubic structure. So ductility is an important factor in ensuring integrity of structures by enabling them to sustain local stress concentrations without fracture. In addition, structures are required to be of an acceptable strength, which is related to material's yield strength. In general, yield strength of a material increases, there is a corresponding reduction in fracture toughness. A reduction in fracture toughness may also be attributed to embrittlement effect of impurities or for body-centered cubic metals. From a reduction in temperature, metals and particular steel have a transitional temperature range where about this range metal has acceptable notch. Above this range, no notch ductility, while below this range material may become brittle. While range materials behave A reduction in fracture toughness may also be attributed to embrittlement effect of impurities or for body-centered cubic metals. From a reduction in temperature, metals and in particular steel have a transitional temperature range where above this range metal has acceptable notch ductility, while below this range of material becomes brittle below this range. Within range materials behave as unpredictable. Within range materials will behave as unpredictable. Reduction in fracture or toughness is accompanied by change in fracture appearance when above transition. Fracture is primarily due to microwide coalescence, which results in fracture appearing fibrous. When temperature falls, fracture will show signs of cleavage facets. These two appearances are visible by naked eye. Brittle fracture in steel plates may appear as chevron marking under microscope. So we can say a fracture toughness measured. No. Fracture, so we have seen here brittle fracture in steel plates may appear as chevron markings under microscope. These arrow-like ridges on cracked surface points towards the origin of fracture. Fracture toughness is measured using a notched and pre-cracked rectangular specimen of which dimensions are specified in standards, for example ASTM E23, or there are other means of estimating or measuring fracture toughness by following Sharpie impact test for ASTM A370, crack tip opening displacement CTOD test for BS74481, J integral test for ASTM E1820, Parallelly drop weight test for ASTM E208, and we will do unusual conditions. Hold on pause. While many welding applications are done in controlled environments such as factories and repair shops, some welding processes are commonly used in a wide variety of conditions such as open air, underwater and vacuums, such as space. In open air applications such as construction and outdoor repairs, shielded metal arc welding is most common process. That is in open air applications such as construction and outdoors repairs. Shielded metal arc welding is most common process. Processes that employ inert gases to protect weld cannot be readily used. Processes that employ inert gases to protect weld cannot be readily used in such situations because unpredictable atmospheric movements can result in faulty weld. Shielded metal arc welding is also often used in underwater welding in construction and repairs of ships, offshore platforms and pipelines. But others such as flux core arc welding and gas tungsten arc welding are also common. Welding in space is also possible. It was first attempted in 1969 when Russian cosmonauts during Soyuz 6 mission when they performed experiments to test shielded metal arc welding, plasma arc welding and electron beam welding in a depressurized environment. Further testing of those methods was done in following decades, and today researchers continue to develop methods for using other welding processes in space, such as laser beam welding, resistance welding, and friction welding. Advances in these areas may be useful for future endeavors similar to construction of International Space Station, which could rely on welding for joining in space parts that were manufactured on Earth. Safety issues. Welding can be dangerous. Welding can be dangerous and unhealthy if proper precautions are not taken. However, using new technology and proper protection greatly reduces risks of injury and death associated with welding. Since many common welding procedures involve an open electric arc or flame, risk of burns and fire is significant. This is why it is classified as hot work process. To prevent injury, welders wear personal protective equipment in form of heavy leather gloves and protective long sleeve jackets to avoid exposure to extreme heat and flames. Synthetic clothing such as polyester should not be worn since it may burn, causing injury. Additionally, brightness of weld area leads to a condition called arc eye or flash burns. Additionally, brightness of weld area leads to a condition called arc eye and flash burns, in which ultraviolet light causes inflammation of cornea. Ultraviolet light causes inflammation of cornea and can burn retinas of eyes. Goggles and welding helmets Googles, not Google, Goggle, Google it is. Googles and welding helmets with dark ultraviolet filtering face plates are worn. Googles and welding helmets with dark ultraviolet filtering face plates are worn to prevent this exposure. Since 2000, some helmets have included a faceplate which instantly darkens upon exposure to intense UV light. To protect bystanders, welding area is often surrounded with translucent welding curtains. To protect bystanders, welding area is often surrounded with translucent welding curtains. These curtains made of a polyvinyl chloride plastic film. These curtains made of polyvinyl chloride plastic film shield people outside welding area from ultraviolet light of electric arc, but cannot replace filter glass used in helmet. Welders are often exposed to dangerous gases. Welders are often exposed to dangerous gases and particulate matter. Processes like flux cored arc welding and shielded metal arc welding procedure produce smoke containing particles of various types of oxides. Processes like flux cored arc welding and shielded metal arc welding produce smoke containing particles of various types of oxides. Size of particles in question tends to influence toxicity of fumes, with smaller particles presenting a greater danger. This is because smaller particles have ability to cross blood-brain barrier. Fumes and gases such as carbon dioxide, ozone, and fumes containing heavy metals can be dangerous to welders lacking proper ventilation and training. Exposure to manganese welding fumes, exposure to manganese welding fumes, for example, even at low levels, less than 0.2 milligram per meter cube, may lead to a neurological problem or to damage to lungs, liver, kidneys, or central nervous system. Nanoparticles can become trapped in alveolar macrophages of lungs and induce pulmonary fibrosis. Use of compressed gases and flames in many welding processes poses an explosion and fire risk. Some common precautions include limiting amount of oxygen in air and keeping combustible materials away from workplace. Costs and trends. As an industrial process, cost of welding plays a crucial role in manufacturing decisions. Many different variables affect total cost, including equipment cost, labor cost, material cost, and energy cost. Depending on process, equipment cost can vary from inexpensive for methods like shielded metal arc welding and oxyfuel welding to extremely expensive for methods like laser beam welding and electron beam welding. Because of their high cost, they are only used in high production operations. Similarly, because automation and robots increase equipment costs, they are only implemented when high production is necessary. Labor cost depends on deposition rate, rate of welding, hourly wage, and total operation time, including time spent fittings, welding and handling part. Costs of materials includes cost of base and filler material and cost of shielding gases. Finally, energy cost depends on arc time and welding power demand. For manual welding method, labor cost generally makes up vast majority of total cost. As a result, many cost saving measures are focused on minimizing operation time. To do this, welding procedures with high deposition rates can be selected and weld parameters can be fine-tuned to increase welding speed. Mechanization and automation are often implemented to reduce labor costs, but this frequently increases cost of equipment and creates additional setup time. Material costs tend to increase when special properties are necessary, and energy costs normally do not amount to more than several percent of total welding cost. In recent years, in order to minimize labor cost in high production manufacturing, industrial welding has become increasingly more automated, most notably with use of robots in resistance spot welding, especially in automotive industry, and in arc welding. In robots welding, mechanized devices both hold material and perform weld. And at first, spot welding was its most common application. But robotic arc welding increases in popularity as technology advances. Other key areas of research and development include welding of dissimilar materials such as steel and aluminum, for example, and new welding processes such as friction stir, magnetic pulse, conductive heat steam, aluminum, for example, and new welding processes such as friction stir, magnetic pulse, conductive heat steam, and laser hybrid welding. Furthermore, progress is desired in making more specialized methods like laser beam welding practical for more applications such as in aerospace and automotive industries. Researchers also hope to better understand often unpredictable properties of welds, especially microstructure, residual stresses, and a weld's tendency to crack or deform. I repeat, it's an important paragraph. In recent years, in order to minimize labor costs in high production manufacturing, industrial welding has become an increasingly more automated, most notably with the use of robots in resistance spot welding, especially in automotive, and in arc welding, in robot welding, mechanized devices both hold material and perform weld. And at first, spot welding was its most common application, but robotic arc welding increases in popularity as technology advances. Other key areas of research and development include welding of dissimilar materials such as steel and aluminum, for example, and many welding processes such as friction stir, friction stir, magnetic pulse, conductive heat seam, and laser hybrid welding. Furthermore, progress is desired in making more specialized methods like laser beam welding practical for more applications, such as in aerospace and automotive industries. Researchers also hope to better understand often unpredictable properties of welds, especially microstructure, residual stresses, and a weld's tendency to crack or deform. Trend of accelerating speed at which welds are performed in steel erection industry. Trend of accelerating speed at which welds are performed in steel erection industry comes at a risk to integrity of connection. Trend of accelerating speed at which welds are performed in steel erection industry comes at a risk to integrity of connection. Without proper fusion to base materials provided by sufficient time on weld, a project inspector cannot ensure effective diameter of puddle weld. Therefore, he or she cannot guarantee published load capacities unless they witness actual installation. This method of puddle welding is common in United States and Canada for attaching steel sheets to bar joist and structural steel members. Regional agencies are responsible for ensuring proper installation of puddle welding. Regional agencies are responsible for ensuring proper installation of puddle welding on steel construction sites. Currently, there is no standard of weld under review by American Welding. Currently, there is no standard of weld procedure which can ensure published holding capacity of any unwitnessed connection, but this is under review by American Welding Society. Glass and plastic weld. Glass and plastic welds. Glasses and certain types of plastics are commonly welded materials. Glasses and certain types of plastics are commonly welded materials. Unlike metals which have a specific melting point, glasses and plastics have a melting range called glass transition. When heating solid material past glass, transition temperature into this range, it will generally become softer and more pliable. When it crosses through range above glass melting temperature, it would become a very thick, sluggish, viscous liquid, slowly decreasing in viscosity as temperature increases. Typically, this viscous liquid shall have very little surface tension compared to metals, becoming a sticky, taffy and honey-like consistency. So welding can usually take place by simply pressing two melted surfaces together. Two liquids will generally mix and join at first contact. Upon cooling through glass transition, welded piece shall solidify as one solid piece of amorphous material. Let us do it again. It's welding together of two tubes made from lead glass. Now, okay, glasses and certain types of plastics are commonly welded materials. Unlike metals, which have a specific melting point, glasses and plastics have a melting range. Melting range called glass transition. When heating solid material past glass transition temperature, Tg into this range, it will generally become softer and more pliable. When glass crosses through range above glass melting temperature Tm, it shall become a very thick, sluggish, viscous liquid, slowly decreasing in its viscosity as temperature increases. You can say when heating solid material past glass transition temperature Tg into this range, it will generally become softer and more pliable. When it crosses through range above glass melting temperature, it will become a very thick, sluggish, viscous liquid, slowly decreasing in viscosity as temperature increases. Typically, this viscous liquid shall have very little surface tension. It says it will become when it crosses through range above glass melting temperature, it shall become a very thick, sluggish, viscous liquid, slowly decreasing in viscosity as temperature increases. Typically, this viscous liquid shall have very little surface tension compared to metals, becoming a sticky, taffy to honey-like consistency. So, welding can usually happen by simply pressing two metal surfaces together. Two liquids will generally mix and join at first contact upon cooling through glass transition. Welded piece will solidify as one solid piece of amorphous material. Glass welding. Glass welding is a common practice during glass blowing. It's used very often in construction of lighting. It's used very often in construction of lighting, neon signs, flash tubes, scientific equipment, and manufacture of dishes and other glassware. It's also used during glass casting for joining hulls of glass molds. Making items such as bottles and jars. Welding glass is accomplished by heating glass through glass transition, turning into a thick, formable liquid mass. Heating is usually done with a gas or oxy gas torch or a furnace. Because temperature for melting glass are often Temperatures for melting glass is often quite high. This temperature may vary depending on type of glass. For example, lead glass becomes a weldable liquid at around 870 degrees Celsius and can be welded with a simple propane torch. On the other hand, quartz glass is fused silica. Then we can say 870 degrees Celsius can be welded with a simple propane torch. On the other hand, quartz glass which is fused silica must be heated to over 1650 degrees Celsius, but quickly loses its viscosity and formability if overheated. So an oxyhydrogen torch must be used. Sometimes a tube may be attached to glass, allowing it to be blown into various shapes. Sometimes, you know, Forrest says oxyhydrogen torch must be used for that case. Sometimes a tube may be attached to glass, allowing it to be blown into various shapes such as bulbs. We attach tubes to. Sometimes a tube may be attached to glass, allowing it to be blown into various shapes such as bulbs, bottles and tubes. When two pieces of liquid glass are pressed together, they shall usually weld very readily. Welding a handle into a pitcher can usually be done. Welding a handle onto a pitcher can usually be done very readily. When two pieces of glass are pressed together, they will usually weld very readily. Welding a handle onto a pitcher can usually be done with relative case. However, when welding a tube to another tube, a combination of blowing and suction and pressing and pulling is used to ensure a So we can say in this case, however, when welding a tube to another tube, a combination of blowing and suction and pressing and pulling is used to ensure a good seal, to shape glass and to keep surface tension from closing the tube on itself. Sometimes a filler rod may be used, but usually not. But it says, however, when welding a tube to another tube, a combination of blowing and suction and pressing and pulling is used to ensure a good seal, to shape glass and to keep surface tension from closing tube on itself. Sometimes a filler rod may be used, but usually not. Here is a photo, a ball made from cast glass. Two halves are joined together by weld seam running down middle. Because glass is very brittle in its solid state, it's often prone to cracking. It's often prone to cracking upon heating and cooling, especially if heating and cooling are uneven. This is because brittleness of glass does not allow for uneven thermal expansion. Glass that has been welded shall usually need to be cooled very slowly and evenly through glass transition in process called annealing. Annealing, Anneal, annealing, to relieve any internal stresses created by temperature gradient. There are many types of glasses, and it's most common to weld using same types. Different glasses have often different rates of thermal expansion, which can cause them to crack upon cooling when they contract differently. For instance, quartz has very low thermal expansion, while soda lime glass has very high thermal expansion. When welding different glasses to each other, it's usually important to closely match their coefficients of thermal expansions. To ensure that cracking does not occur, also some glasses will simply shall simply not mix with others, so welding between certain types may not be possible. When welding different glasses to each other, it's usually important to closely match their coefficients of thermal expansion to ensure that cracking doesn't occur. Also, some glasses it's simply not mixed with others, so welding between certain types may not be possible. Glass can also be welded to metals and ceramics. Although with metals, process is usually more adhesive to surface of metal rather than combination or commingly of two metals. Glass can also be welded to metals and ceramics, although with metals process is usually more adhesive to surface of metal rather than a commingly of two materials. However, certain glasses shall typically bond only to certain metals. For example, lead glass bonds readily to copper or molybdenum, but not to aluminum. Tungsten electrodes are often used in lighting but will not bond to quartz glass. So tungsten is often wetted with molten borosilicate glass. We can say tungsten electrodes are often used in lighting but will not bond to quartz glass, so tungsten is often wetted with molten borosilicate glass, which bonds to both tungsten and quartz. However, care must be taken to ensure that all materials have similar coefficients of thermal expansion to prevent cracking, both when object cools and when it is heated again. Similar coefficients of thermal expansion to prevent cracking, both when object cools and when it's heated again. Special alloys are often used for this purpose, ensuring that coefficient of expansion match coefficients of expansion match, and sometimes thin metallic coating as usual. Special alloys are often used for this purpose, ensuring that coefficient of expansion match, and sometimes thin metallic coating we apply to a monomer. Okay, a special alloys, you can say, however, care must be taken to ensure that all materials have similar coefficients of thermal expansion to prevent cracking, both when object cools and when it's heated again. Special alloys are often used for this purpose, ensuring that coefficient of expansion match, and sometimes thin metallic coating may be applied for plastic welding. Special alloys are often used for this purpose, ensuring that coefficients of expansion match, and sometimes thin metallic coatings may be applied to metal to create a good bond with glass. Plastic welding. Plastics are generally divided into two categories, which are thermosets and thermoplastics. A thermoset is a plastic in which a chemical reaction sets molecular bonds. After first forming plastic, and then bonds cannot be broken again without degrading plastic. Thermosets cannot be melted, therefore, once a thermoset has set, it is impossible to weld it. Examples of thermosets include epoxies. Example of thermosets include epoxies, silicone, vulcanized rubber, polyester, and polyurethane. Plastics are generally divided into two categories as the thermosets and thermoplastics. Thermoset is a plastic in which a chemical reaction sets molecular bonds after first forming plastic, and then bonds cannot be broken again without degrading plastic. Thermosets cannot be melted, therefore once a thermoset has set it is impossible to weld it. So we can say a thermoset is a plastic in which chemical reaction sets a molecular bond after forming plastic, and then bonds cannot be broken again without degrading plastic. Thermosets cannot be melted, therefore once a thermoset is set, it's impossible to weld it. Examples of thermosets include epoxy, silicone, vulcanized rubber, polyester and polyurethane. Thermoplastics by contrast form long molecular chains. Now, thermoplastics by contrast form long molecular chains which are often coiled or intertwined, forming an atmospheric structure, amorphous structures. Uh, Now, thermoplastics by contrast form long molecular chains which are often coiled or intertwined, forming an amorphous structure without any long range crystalline order. Some thermoplastics may be fully amorphous, while others have a partial crystalline, partially amorphous structure. But thermoplastics by contrast form long molecular chains which are often coiled and intertwined, forming an amorphous structure, any long range crystalline order. Some thermoplastics may be fully amorphous, while others have a particular crystalline, partially amorphous, such as so thermoplastics by contrast form long molecular chains which are often coiled or intertwined, forming an amorphous structure without any long range crystalline order. Some thermoplastics may be fully amorphous, while others have a partially crystalline, partially amorphous structure. Both amorphous and semi-crystalline thermoplastics have a glass transition above which welding can occur, but semi-crystallines also have a specific melting point which is above glass transition. Above this melting point, viscous liquids will become a free-flowing liquid. Then see rheological weldability for thermoplastics. Examples of thermoplastics include polyethylene, polypropylene, polystyrene, polyvinyl chloride, and fluoroplastic. Service life. So we can say in this connection, very easy, say that semi-crystalline thermoplastics have glass transition above which welding can occur, but Semi-crystalline also have a specific melting point which is above glass transition. Although above this melting point, viscous liquid will become a free-flowing liquid. And examples of thermoplastic include polyethylene (PE), polyethylene membrane (EC), polypropylene, and polystyrene, polyvinyl chloride, and fluoroplastic like Teflon and Spectralone. Teflon PTF is Teflon. So these are, you can say, thermoplastics. Welding thermoplastics is very similar to welding glass. Welding thermoplastic is very similar to welding glass. Plastic first must be cleaned and then heated through glass transition, turning weld interface into a thick viscous liquid. Two heated interfaces can then be pressed together, allowing molecules to mix through intermolecular diffusion. You can say two heated interfaces can say can then be pressed together, allowing molecules to mix through intermolecular diffusion. Two heated interfaces can then be pressed together, allowing molecules to mix through intermolecular diffusion, joining them as one. Then plastic is cooled through glass transition, allowing weld to solidify. A filler rod may often be used for certain types of joints. Main differences between welding glass and plastic are types of heating methods, much lower melting temperatures, and fact that plastic will burn if overheated. Many different methods have been devised for heating plastic to a weldable temperature without burning it. Ovens or electric heating tools can be used to melt plastics, which respond to induction heating. Some plastics shall begin to burn at temperatures lower than their glass transition. So welding can be performed by blowing a heated inert gas. We may now, a filler rod may be used for certain types of joints. Main difference between welding glass and plastics are types of heating method, much lower melting temperature, and fact that plastics will burn if overheated. Many different methods have been devised for heating plastic to a weldable temperature without burning it. Ovens or electric heating tools can be used to melt plastic. Ultrasonic, laser or friction heating are other methods. Resistive metals may be implanted in plastics, which respond to induction heating. Some plastics shall begin to burn at temperatures lower than their glass transition. So welding can be performed by blowing a heated inert gas onto plastics. Okay, so now Ovens and electric heating tools can be used to melt plastic. Ultrasonic laser or friction heating are other methods. Resistive metals may be implanted in plastics which respond to induction heating. Some plastics begin to burn at temperatures lower than their glass transition. So welding can be performed by blowing a heated inert gas onto plastics, melting it while at the same time shielding it from oxygen. Many thermoplastics can also be welded using chemical solvents. Chemical solvents, when placed in contact with plastic, solvent begin to soften it, bringing soft surfaces into a thick liquid solution. When two melted surfaces are pressed together, molecules in solution mix join them as one. Because 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 solvent can permeate plastics. Solvent can permeate plastics. Solvent evaporates out through surfaces of plastics, causing weld to drop out of solution and solidify. A common use for solvent welding is for joining PVC. A common use of for solvent welding is for joining PVC or ABS. ABS is acrylonitrile, acrylonitrile, butadiene styrene, pipes during plumbing or welding styrene and polystyrene plastics. In construction of models, solvent welding is especially effective on plastics like PVC, which burn at or below their glass transition, but may be ineffective on plastics like Teflon or so it was about below glass. So solvent welding is especially effective on plastics like PVC, which burns at or below their glass transition, but may be ineffective on plastics like Teflon or polyethylene that are resistant to chemical decomposition. So we can go back to see what we have done or learned. It's welding, interesting one. And now we'll go to our quality understanding of this welding method statement, which is actually our requirement. In this we have gone to see what was welding statement in fact. And scope is it applies to operations involving use of different types of welding and cutting equipment, their accessories and related materials. This is our scope in this method statement, and which is very much interesting one here. And purpose of this statement to outline basic requirements for managing or organizing and controlling welding operations. SHE explain many hazards likely to be encountered, assure that procedures be well understood and required safety precautions are implemented. Main hazards which we observe are welding high temperature causing burns and fire. This is the first one, that welding high temperature causing burns and fire. Directly or indirectly evolved fumes liable to cause injury to health. Thermal radiation causing burns and arc eye, oxygen insufficiency or enrichment within confined space, electric shock which may also lead to a fall, explosions often fatal during welding of tanks, drums and vessels which have not been fully freed of inflammable contents and inert gas burst, cause risk of catching fire in vapor, cloud environment conditions. These are a few one. I repeat this, it's very important from every viewpoint. Says purpose of this statement, you can say purpose of this procedure of the statement same is to outline basic requirements for organizing welding operations. SHE explain main hazards likely to be encountered, assure that procedures be well understood and required safety precautions are implemented for encountering hazards which are as follows or which may be more in that. These are only brief hazards I'm trying to give here, and that is, welding high temperature causing burns and fire. Welding high temperature causes burn and fire. Directly or indirectly evolved fumes liable to cause injury to health. Their thermal radiation causing burns and eye arc eye. Oxygen insufficiency or enrichment within confined space. Electric shock, which may also lead to a fall. Explosions often fatal during welding of tanks, drums and vessels which have not been fully freed of flammable contents and inert gas burst. Cause risks of catching fire in vapor cloud environment conditions. Definitions. It's repetitive, but because this is welding one, let us see. Safety means safety, health and environment discipline to support project activities. Company, as we defined before, contractor we defined before, subcontractor we, client and personal responsibilities, training and management, safety, project management. Okay, let's go further. Competent person, empirical standards is stand to be consulted with respect to this process. So, competent person, a person nominated as competent to assume overall control of welding and cutting operations. British standard BS 638-694-6158 standards to be consulted in respect of this procedure for detailed information related to welding and cutting equipment safety, designs and operations, responsibilities in general respecting certain contract positions, and these are, I think, same as before: project leader, site leader, safety one, construction leader, project site engineer. So there's nothing specific in this. Certified welder is very important here. Certified welders in relevance to job requirements are available. That's why I have to make sure. Certified welders in relevance to job requirements are available within valid test pass certificates. With valid test pass certificate, if not available, welders shall be sent for qualifying that test. So let us see this. EPC contractor, what is this? Supervision of all activities subcontractor shall be carrying out on welding and cutting operations, ensuring that work method statements and risk assessments have been carried out as required by nature of WNC processes. A risk study shall be prepared ensuring that work method statement and risk assessment have been carried out as required by nature of welding and cutting processes. A risk study shall be prepared for works in confined spaces prior to individual welding cutting process. Agreeing position of welding equipment in relation with other running equipments, activities, processes. Ensure that certain work permits that may be required are provided. Competent person. For purpose of this procedure, whoever subcontractor organization involved in welding and cutting operations on site shall appoint a competent person approved by PC contractor to have overall control of WC operations or welding and cutting operations. Competent person's duties specified cover assessment and planning of welding and cutting activities. Assessment and planning of welding and cutting activities with regard to selection of safety gear, equipment, instructions and supervision. Ensure that equipment selected has been adequately inspected and maintained. Arrange for replacement in case of equipment breakdown. Ensure that an effective procedure is implemented for reporting defects, taking into account remedial actions. Responsibility for organization and control of welding and cutting operations, stopping all unsafe operations and reporting all incidents. Act according to requirement in case of fire breakout due to welding effects. So let's repeat. Assessment, what competent person should do means specifically cover is assessment and planning of welding and cutting activities with regard to selection of safety gear, equipment instruction and supervision. Ensure that equipment is selected in adequately inspected and tested, inspected and maintained. Arrange for replacement in case of equipment breakdown. Ensure that an effective procedure is implemented for reporting defects, taking into account remedial actions. Responsibility for organization and control of welding and cutting operations, stopping all unsafe operations and reporting all incidents, acting according to requirement in case of fire breakout due to welding defects. Instructions. Accidents involving failure and damage to welding and cutting equipment are frequent on construction sites and usually of very severe nature. When do occur? Cause factors leading to such accidents include operator's error, inadequate inspection and maintenance of equipment, failure to plan operation and not to adopt precautions, poor connections and existence of obstructions on lines, right of way, overload and or misuse of equipment. Overload and misuse of equipment then. Gas flame. In equipment talk of gas flame, that is gas flame equipment. Gases commonly used are oxygen, acetylene and propane. Oxygen, acetylene and propane. Oxygen enriched air can be very dangerous because in such atmosphere flammable material can easily be ignited, burn fiercely and also difficult to ignite materials which can become highly combustible. Activities that can cause oxygen enrichment are excessive purging. Activities that can cause oxygen enrichment are excessive purging, leaks from equipment, hoses, connections, supplies being left on, flame cutting which can discharge up to 30% unconsumed oxygen into atmosphere. Oxygen cylinders valves should always be opened slowly. Oxygen cylinder valves should always be opened slowly, cleaned with a dry cloth or paintbrush which is free from grease and oil stains. Confined spaces where oxygen enrichment may occur greater than 20.8% should be regularly checked by a competent person using a suitable oxygen meter. Acetylene cylinders should always be stored upright. Now, oxygen cylinder valves should always be opened slowly, cleaned with a dry cloth or paintbrush, which is safe, which is free from grease and oil stains. Confined spaces where oxygen enrichment may occur greater than 20.8% should be regularly checked by a competent person using a suitable oxygen meter. Acetylene cylinders should always be stored upright because of their design assumptions as such. Pressure in hose should not exceed zero point 0.6 bars. Copper pipes must not be used as copper reacts with it and forms an explosive material, copper acetylide. Copper pipes must not be used as copper reacts with it and forms an explosive material, copper acetylides. LPG propane cylinders on release of propane, which is heavier than air, to atmosphere. Shall readily collect in ducts and drains, etc., posing a risk of explosion, fire, and asphyxiation. Fuel gas and oxygen supplies should be stored separately, at least 6 meters apart in open. If kept inside, store should be of fire resisting construction with ventilation provided at top and bottom. Lighting illumination to store should be either from outside store or structure should be made of flame-proof construction. All cylinders in use must be kept secured in either a cylinder trolley or lashed to a suitable support. Acetylene and propane cylinders all cylinders in use must be kept secured in either a cylinder trolley or lashed to a suitable support. Acetylene and propane cylinders must always be used in upright position because liquid may discharge through valve or damage equipment. Also, if high pressure cylinder falls and its valve breaks, it can behave like a rocket and travel jet considerable distance, causing serious injury and damage. Namely, oxygen cylinders operate at 122 bars. Acetylene and propane cylinders must always be used in upright position because liquid may discharge through valve and damage equipment. Also, if high pressure cylinder falls and its valve breaks, it can behave like a rocket and travel jet considerable distance, causing serious injury and damage. Namely, oxygen cylinders operate at 172 bars. All cylinder valves must be closed when not in use. Cylinders should not be rolled along on ground. If a trolley is not available and or other forms of transport must be used, cylinders must be firmly secured before moving. Cylinders must never be moved with magnets or chain slings. Valve spindle or connections should never be lubricated. Says cylinders and fittings must be kept far away. Says valves, spindles and connections should never be lubricated with oil or grease. Cylinders and fittings must be kept far away from corrosive substances, oil and grease from overhead equipment, electrical welding tools, welding sparks and other heat sources. Cylinders should never be used as a structural means of support or as an electrical earth medium. Regulators, gauges, hoses and torches must be of correct type for gas being used and should be checked regularly to ensure gas tightness. Spark lighter should be used in preference to matches or smoldering gas. Check hose, valve, thread and cylinders color code. What are those? Gas, cylinder color, valve thread and hose. Oxygen is black cylinder color. Oxygen is black cylinder color. Valve thread is right-handed. Hose is blue. Acetylene, maroon color cylinder. Valve is left-handed. So you can say oxygen cylinder is black, hose is blue, acetylene cylinder is maroon, hose is red, propane is red, orange is its hose. So oxygen black right-handed, blue, acetylene maroon left-handed, red, propane red left-handed, orange. Each hose should be securely attached to its connections by means of suitable hose clips or clamps. If hoses have to be connected together, approved couplers should be used. Damaged hoses should be replaced without delay. Leaks must not be searched. We can see now Each hose should be securely attached to its connection by means of suitable hose clips or crimps if hoses have to be connected. Hoses together, approved couplers should be used, damaged hoses should be replaced without delay. Leaks must not be searched for using a naked flame. Leaks must not be searched for using a naked flame but with a suitable solution of soap and water. Leaks must not be searched for using a naked flame but with a suitable solution of soap and water. Flashback arresters and hose check valves must be fitted to both oxygen and fuel gas regulators and manifolds. Flashback arresters and hose check valves must be fitted to both oxygen and fuel gas regulators and manifolds. Arresters shall stop and extinguish a flashback. Arresters shall stop and extinguish a flashback. Prevent reverse flow of gas. Shut off supply of gas following a flashback. Hose check valve must also be fitted in hose connectors. Hose check valve must also be fitted in hose connectors at torch to prevent backflow of gases. Electric arc equipment. Mobile engine driven generators. Mobile engine driven generators should be sighted so as to no danger or to health arises either from exhaust gases or from high noise levels. So electric arc equipment is mobile engine driven generators should be sighted so as no danger to health arises either from exhaust gases or from high noise levels. It should be located far away from work area and extension leads provided to bring welding electrical supplies to work point. Generators should be located to ensure as far as possible that cables do not constitute a tripping hazard. Where running of cables along ground is unavoidable, they should be neatly arranged and properly protected against pedestrians or vehicle damage. All mechanical guards should be in proper position and a safe means should be provided to start engine. Fuel drum or bulk supply tank. Fuel drum or bulk supply tank must be located in a safely positioned storage area. Fuel drum or bulk supply tank must be located in a safely positioned storage area. Engine must be switched off while refueling is done. Fuel leak must be cleaned up and integrity of fuel connections checked. Welding transformers and rectifiers. Welding transformers and rectifiers are connected to mains. Welding transformers and rectifiers are connected to mains, often for 15 volts from a 3-phase supply. All electrical equipment must be installed and maintained by a competent electrician. Welding transformers must be connected to main supply. Welding transformers must be connected to main supply by heavy duty cables. Welding transformers must be connected to main supply by heavy duty cables. An efficient isolating switch together with protective fuses or circuit breakers should be located in an accessible position. An efficient isolating switch together with protective fuses or circuit breakers should be located in an accessible position. Fixed transformers should be permanently wired. Fixed transformers should be permanently wired in route, conduit or armored cables used instead. Cases of both portable and stationary sets must be given earth to provide protection to casing faults. Workpieces. Workpiece should, whenever practicable, be earthed by an independent earth lead. Earth connection must be capable of carrying secondary current without damage. Cable similar to that of welding circuit shall be suitable. A properly constructed and installed electrode holder should be used. It should have insulated handle. Holder should be well balanced and easy to work with. Provision should be made for safely accommodating electrode holder. When not in use, industrial type plugs and sockets are to be available for this purpose. Electric arcs for welding do not normally exceed 100 volt AC or DC. However, there is still a risk of short circuit and electrical fires. Therefore, all electrical equipments, auxiliary cables and connections should be checked frequently. Transformers, rectifiers and associated electrical equipment should be protected from moisture and dust. Dirty connections in particular can overheat and start fires. Protective clothing, headgears and screens to protect passerby from arc flash are essential. Correct eye shields must always be worn to protect eyes from arc flash. These can be handheld or helmet type shields. Welding and cutting hazards. Heat and fire risks, there is heat and fire risk and I think should take it later. It's already more than 3 hours. We'll take it later, remaining one, because this is very important. Alright, I'm going to close it now because it's very important chapter, welding. And we talked a lot about real welding. It's what welding is. Thermoset, various methods we talked of. And I think it's useful in our learning. So let's close it here and move further. Alright.